All right, today we're on Unit 8, Day 7. This is where we're going to be solving by elimination, multiplying possibly one equation or two. Um, yesterday for Day 6 we multiplied one. Today we could multiply more than one, and I think we're adding special cases as well today. So those are the goals. If we take a look at this first example, up top, it first says sometimes to eliminate a variable, you'll need to multiply one or both. Remember, the goal is to have opposite coefficients for at least one of the variables. So when we look at this first example on the left, I notice that my x's or y's can be chosen to eliminate if we have to multiply both. The easiest way to do this is to eliminate the x's or whatever's on the left side. So if we just take the number that is on the top x and multiply it by the bottom, and the number that's on the bottom and multiply it by the top, and make sure that they're going to be opposites as far as the sign goes, then you're always going to be able to cancel out those first variables. So I didn't multiply by -2 up top because it was already negative, and I want one to be positive, one to be negative. So if I multiply this 2 by all three, I'd get 10x plus 6y is equal to -24. If I multiply this 5 by all three, I get -10x plus 10y is equal to 40. And then just like yesterday, we're going to add these two equations together. So the 10x's will cancel. I'll be left with 16y is equal to 16 if we add 40 plus -24. We divide by 16 and we get y equals 1. So that's half of our answer is the 1 for y. But we need to find the other half by plugging in 1 for y. So we can do it to the top or the bottom equation. It doesn't matter which one. It'll give you the same answer. So if we do it to the top, that'd be 5x plus 3y equals -12. We need to plug in 1 for y now. Instead of a y there, I plugged in 1. So now that's 5x plus 3 equals -12. We subtract the 3, and we get 5x is equal to -15. So we would divide by 5 in order to get x by itself, and we get x equals -3. So that would be my final answer, would be -3 comma 1. That would be for the first one. For the second one, if we use that strategy that I talked about, taking the top number and multiplying it by the bottom, and the bottom number and multiplying it by the top, they would both be +10. So in order to make one of them a negative, you just got to choose. It doesn't matter if you choose the top or the bottom to plug a negative on the outside as well for the number that you're multiplying by. So I chose the top. You could choose the bottom. It'll give you the same exact answer. It doesn't matter. So if we were to multiply this in, we get -10x minus 15y equals -35. In the bottom, if we multiply it all the way through, we get 10x plus 8y is equal to 28. If I add these two equations together, the 10x's cancel. I'm left with -7y equals -7. Divide by -7, and you get y equals 1 again. So we got 1 twice now. And then we plug this in to the top or bottom. It doesn't matter. I'll plug it into the top. We'll see what we get for x. So it'd be 2x plus 3 times 1 equals 7. So that'd be 2x plus 3 equals 7. Subtract 3 from both sides, and you get 2x equal to 4, and x equal to 2. So 2 comma 1 would be your answer for the right side one. If we keep moving along to the next page has some of our special cases. Our two special cases that we have, that we've learned about so far, are the ones that are many solutions, that's two lines on top of each other, or no solutions. Those are two parallel lines. We can get those two answers like we've done before with substitution. We can get them through elimination method too. So it says when the variables cancel out and you get a true statement, such as 0 equals 0 or 5 equals 5, then the system has many solutions. And that's what you learned when we did substitution. If you cancel out the variables and you get a false statement, such as 0 equals 1, that's false, or negative 5 equals positive 5, that's false, that means that there's no solutions. So I'm guessing down below here, we're going to have some problems that will give us one of those two, or possibly even give us an answer. I guess we'll find out and see in just a second. So now, if we take a look at the first one, I notice that the x's and the y's are already exact opposites of each other. So they would cancel. So all my variables cancel. 3 plus 5 gives me 8. I have to ask myself, does 0 equals 8? Is that a true or a false statement? 0 does not equal 8 ever. So that would be a false statement. So if it's false, we said that there's no solution. And that would be your answer. That's all you got to do. For number 11, we have to actually multiply by something in order to get the x's or y's to be exact opposites. So I notice the bottom has a 1. So I'm going to multiply the bottom by negative 2 in order to be able to cancel out the x's. So if we multiply that through, that'd be negative 2x plus 4y equals negative 16. I'm going to put the top equation underneath it. So now we have 2x minus 4y equals positive 16. If I added those two equations together, the x's and y's cancel, and I'm left with 0 equals 0, which means many solutions, because that's a true statement. 0 does equal 0. So that covers 10 and 11. Let's go to 12. For number 12, in order to get the x's to be exact opposites, I'm going to multiply the top by negative 3. I think that would give me a negative 9 for my x. So if I multiply it through, I get negative 9x minus 3y equals negative 27. If we add those two together, we get 0 equals 0. So everything would cancel as far as the variables and the constants go. And then that would mean that there's many solutions. So that's my answer for 12. Any questions on that? Hopefully not. And then number 13, I think, is the last one on this page. Yep. We would multiply the bottom by 2. So that would give us negative 4x, and that's what exact opposite of the above. And we get negative 6y is equal to 12. On the top, if I bring it down below, it looks like that. Oh, that's plus 6y, I said. So now let's see what happens here. I think the x's are exact opposite. The y's are exact opposites, and that would be 24. 0 does not equal 24, so that would be no solution in that case. All right, and then the last page, I think, is got some mixtures now. So we'll do a couple mixtures here. All right, so I think we talked about multiplying the top by the number on the bottom and the bottom by the number on the top, making sure at least one of them is negative. So one of them is already negative, so I don't have to worry about multiplying by negative. So if I multiply the 5 into this, we would get negative 35x plus 40y. 5 times 30 is 150. I think that's 160. If I multiply the 7 in, that'd be 35x plus 42y. 7 times 20 is 140 plus 28 is 168, I believe. So now I notice that the x's will cancel each other out, and that was our goal. And then we'd be left with 82 82y is equal to 328. Divide by 82. And I have y equals 4. And then I have to plug that back into either the top or the bottom. It doesn't matter. I'll choose the bottom. So I have 5x plus 6 times 4 is equal to 24. So it'd be 5x plus 24. We subtract the 24. We get 5x equals 0. So x equals 0. So 0, 4 is your answer for number 1 on the back here. Number 2, it looks like I just need to multiply the bottom by -2 in order to cancel out the x's. So if I multiply the bottom, it's kind of an ugly 2 here, by -2, I would get -4x minus 6y is equal to 16. So now the x's will cancel. I'm left with -11y is equal to 22. Divide by -11. And I have y equals -2. A little ugly again with the 2. And then I plug that back in. I'll plug it into the top. It doesn't matter which one you choose. So now I get 4x plus 10 equals 6. Subtract 10, I get 4x equals -4. So in the end, I get x equals -1, it looks like. So that'd be your answer for the second one. Leave that up for a second. And now I'll do one more. So for number 3, I'm going to do the y's. I'm going to cancel out the y's because you don't have to always cancel out the x's. So if we take the bottom number for the y, which is 3, and the top number for the y, which is -4, and just multiply the top by the bottom and the bottom by the top, I already noticed that they're opposites as far as their signs go, so I kept them both positive. This should cancel out the y's. So if we distribute this correctly, we get 15x minus 12y is equal to -90. Multiply it in, and I get 8x plus 12y is equal to -48. So I'd add together the x's, get 23. The y's cancel. I'm left with -138. Divide by 23. Oopsie. And I get x equals, I don't know what that is, -138 divided by 23. -138, 23, -6. Okay, good. So you get -6 for your x. So that's half our battle. And then we got to plug that into either the top or the bottom. It doesn't matter which one. I'll plug it into the top here. So 5 times -6. So I get -30. Add 30 to both sides. Divide by -4. And I get y equals 0. So that'll be my other half. So -6 comma 0 is my answer for number 3. And I think that's enough practice goes for this. So then you guys are on your own for the rest of it.